Okay guys, so we're going to start the last thing of our series and sequence unit, and that's going to be binomial expansion. So binomial expansion means taking a binomial, something like x plus y squared, and instead of leaving it factored, writing it out with all of its terms. So the first thing we're going to look at is this triangle over here. Now this is something you may have seen before. It's called Pascal's triangle. And where you get these numbers from is, let's say, I take 1 plus 2. That gives me the number below, which is 3. So 1 plus 3 gives me the 4. So I can come up with this next row here simply by adding the two numbers right on top of it. Now this triangle actually is going to help us to find some of these coefficients. Now we're not going to use this for every case. This is just one example of some of the patterns that we're going to see here. So let's take, for example, a real simple binomial, like x plus y to the 0 power. Now that's one we all know. Anything raised to the 0 power is just 1. Alright, let's take another basic one. X plus y to the first power. Well, we know anything to the first power is just itself. Then we take, like our example, x plus y squared, and that's one we've worked out many times. We know that's going to be x squared, plus you multiply the two terms and double, so that's 2xy. That last term is y squared. And then if we were to take x plus y cubed, if we actually multiplied that out, we multiplied x plus y times itself 3 times, I would get x cubed plus 3x squared y plus 3xy squared plus y cubed. And now hopefully you guys can kind of see a pattern here with these coefficients that I have and the numbers on my triangle. So if you look, x plus y to the 0 power, I just got 1, which is the coefficient that's on my triangle. If you look at x plus y to the first power, I get 2 coefficients, and those coefficients are 1 and 1, which is exactly that row in the triangle. So I'm going to label that first one as 0, and that second one is 1. Now that second row, x plus y squared, I have those same coefficients, 1, 2, and 1. Now right now we're just looking at those coefficients out in the front. We'll worry about the variables in a little bit. Then again, if you look at this cubed one, I have coefficients of 1, 3, 3, and 1, which match up with my triangle. Now while this triangle is nice and it shows us these patterns, we're not necessarily going to want to use the triangle if we were looking for a term of the binomial, say, x squared plus 3y to the 48th power. We're not going to want to do that many rows from my triangle just to find one term of that binomial. So there's another way that we can find these coefficients and these numbers in that triangle, and that is using our last formula for binomial coefficients. So this one obviously looks very different from the formula we've been using in the past. So the first thing we're going to do is we're just going to use this formula once to see how it works and what it actually means. Then we'll see how it applies to what we just did. So if you look, your examples using this formula, you'll have something in parentheses like this 5 and 4, and then we'll use that formula that we were given. So if I take this 5 and this 4, this would plug into my formula as the top number with an exclamation point divided by the bottom number with an exclamation point, and then subtract those two numbers, and they get the exclamation point. Now if you remember from Algebra 2, that exclamation point means factorial. So that's 5 factorial. And 5 factorial means 5 times 4 times 3 times 2 times 1. So I take that number and multiply it by every number that's smaller than it. So for example, 4 factorial, that means 4 times 3 times 2 times 1. And then this is still multiplied by just that 1. Now the reason these are actually usually pretty simple to work out is if you look here, I've got 4 times 3 times 2 times 1, which cancels out with 4 times 3 times 2 times 1. So all I have left in this whole equation is just 5. Now what that means is that 5 is one of my binomial coefficients for a certain place. So we'll explain what that formula means. So if you look, this top number here, this 5 here, matches up with the power of the binomial. So this would be a coefficient for a 5th degree binomial, so like x plus y to the 5th power, or 7x minus 2z to the 5th power, anything raised to the 5th power. What that bottom number helps us do is figure out which specific term it is. So there are going to be multiple terms, as we saw in the ones we just did. So this is r plus 1 is the term that I'm looking for. So in this case, my r is 4. That means that this would be the fifth term. So this would be the fifth term in some binomial raised to the fifth power. That would be the coefficient. Okay, now we're going to look at a couple of specific examples that come up a lot in that triangle and also will come up a lot in our formulas. So if I have n and 0, n is any number, right? So if I have any number over 0, what that would mean for us is I would end up getting in that formula, let's say I have 5, 0. Well, that would work out to be 5 factorial over 0 factorial. And then I have 5 minus 0 factorial. Now, one thing that you guys might have learned about this in Algebra 2, 0 factorial is just the number 1. But 5 factorial over 5 factorial, anything divided by itself, again, is 1. So what that means is any number over 0, that coefficient is 1. And again, if you think about that triangle we just had, 0, okay, would be the first term, because 0 plus 1 is my first term. Every single first term on that triangle was 1. Okay, well, if my numbers match, okay, so if I have 5 over 5, okay, let's say, or I have 7, 7, like this, well, that is always going to be my last term, okay, because no matter how many, whatever degree you're raising it to, you'll have one more term than that. For example, x plus y squared had 3 terms. So if those two numbers match, that's going to be my last coefficient, and every time that last coefficient is 1. Then two others that are pretty common, let's say I have n and 1. So some number, again, like 7 and 1. Well, the way that would work out in my formula, that would be 7 factorial divided by 1 factorial, and then 7 minus 1 factorial, which is 6 factorial. Well, I know from 6 factorial is going to divide out everything from that 6 on, so all I'd have left is that 7. So every time I have just some number over 1, that's going to work out to just be that number. Same thing if it's that number and 1 less. It would just work out to be that number. Again, if you go back and look at that triangle, every second term and second to last term was the same as that row we were looking at. Okay, so those are just some common ones that you'll see, just to kind of save you a little bit of time. Now the last part on here that we haven't talked about yet is how this relates to those exponents in that term. So if I do n minus r, if I subtract those, that's the exponent of my first term. And then r, that's going to be the exponent of my second term. Okay, so let's look at a basic example here. I had x plus y squared, and that was the same thing as x squared plus 2xy plus y squared. So if you look, for each of these terms, this first one would have been, the coefficient is 2, 1. The second one, the coefficient is, I'm sorry, that should be 2, 0. The second one, that coefficient is 2, 1. And that last one, my coefficient is 2, 2. So those coefficients work out if I were to do that factorial formula. But what I'm talking about with the exponents, that helps us by looking at this. If I look at n, okay, n minus r in this first case is 2. And 2 is the exponent on my x. 2 minus 1, that's my exponent on my x. 2 minus 2 is 0, and there are no x's in my last term. And then if you look at that bottom number, that r, there are 0 y's, so there's 0 exponents on this one in the first term. Then there is 1 in the second one, and there's 2 on the last one. Now I know this is a lot, but we're going to break this down a little bit, and we're going to look at a couple of examples. Okay, now what we have written here, this is the actual binomial theorem. This is just a very mathematical explanation of what we've been doing. So this is the way that we can expand any binomial without actually multiplying it out. So what this tells us is if I have x plus y raised to the n power, that's how I find my coefficients. So if you look at those coefficients there, I start with the degree of the binomial, 0 for a coefficient. Degree of the binomial over 1 is a coefficient. and then over 2, and then I keep going until it's 1 less than the number, and then my last coefficient is when those numbers match. So that helps us with the coefficients. Then if you look, it just shows you how those exponents work, which is exactly what we just explained. Okay, we start with none of the second term, and then the highest number of that first term. Alright, now we're actually going to look at an example here to see if we can make this a little bit simpler. So what we're going to do is we're going to expand this binomial. And what we're going to do is we're just going to go step by step and follow the rules we just talked about previously. So the way this is going to work, this is a binomial raised to the third power. So the first thing I'm going to do is I'm going to come up with my first coefficient. So that first coefficient, what's going to come in parentheses? 3 goes on top because this is raised to the third power, and it's the first term, so it's a 0. Then what I'm going to do is I'm going to write the term, and I'm going to raise it to a power. So my first term here is this 2a. So I'm going to take that 2a, and that 2a is going to be raised to the third power. Because remember, that first term, what it gets is the top number minus the bottom number. So 3 minus 0 is why it's raised to the third power. Then I'm going to do my last term here, and that's just going to be this b squared. And the b squared is going to be raised to the 0 power, because my second term, I use the exponent of the bottom number. And we know anything to the 0 power is just 1, so that goes away. Now what I'm going to do for now is I'm just going to write these out, and then I'll actually evaluate them at the very end. Because remember, we know that 3, 0 in parentheses actually has a number to it. Okay, now we're going to go on to the next term. So my next term, I'm going to have a new coefficient. So I move from 3, 0, I move to 3, 1. So that's my coefficient, and then I take the first term. The first term is 2a. Then I take 2a and I raise it to the 3 minus 1 power. Then I take my second term, which is b squared, and I raise b squared to the bottom number power. And then I move on to my next term. The coefficient still is 3 on top, but now I'm moving up a term, so now this is now going to be 3, 2. I take my first term, so that's going to be 2a. Now it's 3 minus 2, it's just the first power. And then I do my second term, and my second term is going to be raised to the bottom number power. And then I'm going to move on, and I know I'm going to be at my last term now because my coefficient numbers match. It's 3, 3. I take my first term and I raise it to the 3 minus 3 power, so it's 2a to the 0 power, which is just 1, so that goes away. And then finally I'm left with the last term raised to the bottom number power. So now what we're going to do is we're actually going to figure out what these coefficients are and multiply them out. So like this very first one, 3, 0. We talked about this. Any number over 0, that coefficient is 1. So my coefficient here is 1. Then I actually find what this next term is. That's 2a to the third power. That is going to be 8a cubed. Now we move on to the next term. 3, 1. That's the coefficient. Any number over 1 we know is just that number. So that's going to be 3 times, now I'll do the math here. I've got 2a squared, which is 4a squared. And then I've got b squared to the first power, which is just b squared. Then I go to my next term. 3, 2, that coefficient, any number, and if the bottom number is 1 less, it's just 1. Or if you really wanted to, if you couldn't remember that, I could do that factorial formula and do 3 factorial over 2 factorial, 1 factorial, and I would still get 3. Okay, but continuing here, I know my coefficient's 1, which means then I have 1 times 2a times b squared, which is b to the 4th. Then my last one, I know 3 over 3, that coefficient is 1. And then 1, that's times b squared to the third power. A power to a power I multiply, so that's b to the 6th. So now if I really want to simplify this thing out and write the whole thing in one final neat answer, that would be 8a cubed plus 12a squared b squared plus 2ab to the 4th plus b to the 6th. And I know that's pretty long, but you're not always going to have to expand the entire equation. So what we're going to look at now, this last example here, is going to be a little bit simpler because what it's going to do is just take one specific term. So all this wants is the 7th term of this binomial expansion here. So I don't need to actually find the whole thing. And instead of working out all of it just to get this 7th term, I can use what I know about those coefficients to make this a little bit simpler. So what I can do here is I need to find the 7th term. Well, I know this binomial is raised to the 10th power, which means the coefficient here is going to have a top number of 10. And if I'm looking for the 7th term, then I'm going to have 7 minus 1, which is 6, and that's my coefficient. Then, again, I can follow those same rules here. I take the second term, or the first term, and that's going to be raised to the 10 minus 6 power. And then I take the last term, and that's raised to the bottom number power. And then I can work this whole thing out to figure out what this term is going to be. So in order to work this whole thing out, I'm first going to evaluate that 10 over 6. I'm going to do that up at the top here where there's a little bit more space. So 10/6 like this, that's 10 factorial over 6 factorial, 4 factorial. So that means I'm going to have 10 times 9 times 8 times 7, but then times 6 on is going to cancel out with that 6. So all I really have at the top is 10 times 9 times 8 times 7 over 4 times 3 times 2 times 1. And again, I can simplify this even more. I know 4 times 2 is 8. And I know 9 divided by 3 is just 3. So even if I don't have a calculator, which is a little bit easier to do, I'm just going to have 10 times 7 times 3, which gives me 210. So that 10 over 6 there is the same thing. This is 210 times x to the 8th times 2 to the 6th times y to the 6th. Now remember here, when you're finding a term, this is just one term, which means everything here is multiplied together, which means my final answer here, I can multiply 210 by 64. I get my final answer of 13,440 x to the 8th, y to the 6th. And that is my term. Okay, now I know this is a lot, and it seems a little bit complicated. Just remember to take it step by step and just go part by part, and you'll get a little bit easier. Just look for your patterns here and try to remember, especially with those exponents. It's a little bit easier if you just look at the pattern and see what's happening as you go.